If you look up at the sky on a clear night, you get an image like this, or like this maybe. But what you see on a clear night is only a fraction of what scientists think there really is out there. All that you see is just in our galaxy, and we'll talk about the term galaxy in a little bit. But scientists think there are billions of those galaxies. Well, anyway, the planetary beings that you see and beyond what we see, they are in their certain place because of gravity. Now we know what gravity is. Gravity is that force that keeps us on the earth, it keeps us from flying up into the air. That's kind of what happens with the planets or other stars or things out in space. Mercury doesn't just go flying out into space, it is in the orbit around the sun. Earth doesn't just go flying out into space, it's in a predictable position because of its orbit around the sun. It's the gravity of the sun that keeps all these planets in place. Now, it's not just true for planets. You have other stars that are in their place because of the location to it around other planets or other stars. It's like it's going to say not going to just fly out into space. It's going to go in a predictable pattern because of the stars or larger objects around it. Here's what looks like it to be a large star here. It probably has things going around it, and it may have other stars that are going in predictable manners just because of its relationship to this star. So yes, even our sun, which is kind of a mid-sized or even smaller to mid-sized star, it is going to be in a predictable position in the universe just because of gravity, because its relationship to where it is to other stars or other large objects. So kind of the whole point is everything out here in space is where it is because of the gravity of other beings around it, other objects around it. The moon is in orbit around the Earth because of the Earth's gravity. The whole universe is kind of like the moon is to our Earth, like the Earth is to our sun, like the sun is to other stars. Now let me remind you of the term orbit. I used it just a second ago whenever I was talking about Mercury and Earth and Moon. They are going around a larger object because of gravity. They are in orbit. We could send some kind of satellite up over Earth and it will orbit the Earth. It's in moving around the Earth, which is the larger object. Orbit is the path of an object in space as it moves around another object because of gravity. Now there are some terms I'm going to throw at you, and these terms are going to be solar system, galaxy, and universe. First of all, we'll talk about the solar system, which is the smallest of the three. The solar system is, or our solar system is, the Earth and the other planets orbiting around the sun. So all the planets that are orbiting around our sun would be in our solar system. Now let's talk about a different term, a bigger term. Now this is called the Milky Way. But the Milky Way is a galaxy, and I'll try to spell galaxy for you up here. But a galaxy is larger than a solar system. You probably can't see it from where you are, but there's actually our galaxy, or our solar system is labeled inside this galaxy, which is up here, the Milky Way. Our solar system, I don't know if you can see it, is right there. If our solar system were the size of a penny, our galaxy would be the distance from here to Chicago. It's very, very large, much larger than our solar system is. And to kind of give you a perspective on that, If you were to get into a spaceship and travel your entire life, you would not ever get out of our own solar system. It's just going to be almost impossible for us to reach in our lifetime, even if we were to start out on a spaceship at birth, to be able to reach some of these areas that scientists think are out here. So here we are, just a small speck on this big galaxy. So solar system is smaller than a galaxy. But if you're talking about space terms, there's something that's bigger than a galaxy, and that would be the universe. Now, I have a picture here. This picture just happens to be one that was online, but the universe by definition is everything. So it would include more than just one galaxy. Now, you may wonder how many galaxies we have. According to scientists, there are billions of galaxies. So the universe containing everything contains every last one of those billions of galaxies. And that's just beyond our comprehension, because it's kind of hard for us to even grasp the concept of other planets and near our star, near our sun. And for there to be so many more of those just out there that we can't even see is just kind of hard to fathom. Like I think I mentioned earlier, all that we can see in the night sky is just in our galaxy. Just in our galaxy. It's not beyond that, even with a telescope. It's just in our galaxy. Okay, let's talk about a couple of terms. We have constellations. You have a constellation, right, or I guess kind of a semi-map of constellations. A constellation is a group of stars that form in patterns. Now, they only form in patterns because of our perspective. If we were in a different location in the galaxy, then our perspective would be completely different. For example, here we have Cygnus, the swan star. You have the arms of the swan. Here's the body, here's the arms. You have the arms of the star, which are much farther out than some of the other stars. The arms of the star of the constellation may be way over here. The body may be way up here. It's just from our perspective, they appear to be close together, but they in reality are millions of miles apart from each other. It's just because of where we stand here on Earth is why it just looks like it's going together, but it's not. It's just so many millions of miles away. If you were to be on a planet near one of these stars and looking our direction, our sun would be part of some constellation there, some kind of pattern there. Same thing here with the dippers here. This is, I think, is the Little Dipper. You have these stars, which are probably nowhere near each other. And we're going to talk about this particular star, the North Star, in just a second. Have you ever noticed that the stars appear to move during the night? If you're looking up and see a picture kind of like this, and you were to notice a particular star, let's say you had a larger star right here, or had some kind of planet right here. If you look up at, say, 10 o'clock at night, it may appear to be there. But then if you look up at 1 a.m., it will appear to have moved. Then if you look up at 4 a.m., it would appear to have moved again, and it may even be off of our vision. They all appear to be moving in a particular direction. Now you can imagine for people hundreds and even in a couple of thousand years ago who noticed this, that's probably why they imagined that the Earth was the center of the universe, that everything was revolving around it. But that's not the case. We know now that it's a heliocentric universe where it revolves around the sun, not the Earth. I think I'm using that term right, heliocentric, as opposed to geocentric. Yeah, geocentric would be revolving around the Earth, heliocentric revolving around the Sun. But we know all of us are revolving around the Sun, so why does it look like these stars are moving? It's because we're moving. The Earth is spinning, and for every 24 hours, the Earth spins around completely one time. So as a result, whenever we look out and we see this star in this part of the sky at one part of the night, then we keep moving. And then it appears that that star is farther on in the sky. It appears to have moved, but it's not moving. It's because we are moving. Now, you may have noticed this photo down here. This is a time-lapsed photo of the night sky. In other words, this photo, the lens was open for hours, and notice what's happening here. The star that was here appears to have completely moved all the way around. And wow, my circles are not anywhere near as good as nature's circles. But anyway, that's exactly what's happening. If you just, notice the trees are all the same, that they haven't appeared to move. This house hasn't appeared to move, but it's the sky that has appeared to move. Even though the sky is not moving, we are the ones that are moving. It's the Earth that is moving. Now notice what we have here. We have kind of a point right here where everything is spinning around. At that point is where you find, we'll go back to this part right here, where you find Polaris. It's called the North Star. Now you probably have heard about the North Star. If you were to get lost in the woods and you follow the North Star, you will be going north at all points, which makes sense if that star is right here, and it is. Polaris is right here, and it is the one star that stays constant in the sky. If you start following a star that's right here and imagine you're going north, what happens whenever the star is right here? You're following in a big curve. You're not following it, but the star to follow would be this one, which is Polaris. Now, why is it special? It's special because it is if you were to take the Earth's axis and have it go straight out into space, it goes right to Polaris. In other words, Polaris is right above the North Pole. So as a result, while the Earth is spinning, the one that is right above the North Pole appears to stay constant. All those others are the ones that appear to be moving around, but the one that is above the North Pole is the one that appears to stay constant. So that's exactly what's happening here.